All right, so we're going to have two lessons in level 3. We are going to now look at when we have a trinomial or 3 terms, but your coefficient of the x squared term is greater than 1. So if you recall back to when your coefficient of your x squared term was 1, we used something called the box method. Now what happens if your coefficient of x squared is greater than 1? We are going to be using something called the x method. And a reminder, we should always take out our greatest common factor first in order to have your polynomial completely factored. So let's jump in. In number 1, we do not have a greatest common factor, and since we have 3 terms, but the coefficient of your first term is greater than 1, then we're not going to be using the box method. We're going to jump into something called the x method. So what we do with the x method is we draw ourselves an x. In the top of your x, you want your a times your c value. So your a is your first term, your c is your last term. So a 6x squared times a positive 5 is a 30x squared. And in the bottom of your x, we want our b value, which is our middle term, which is a positive 13x. All right, so now we're going to do something similar to what we did in the box method. I need two terms when multiplied together equal a 30x squared, but when added together equal a 13x. Well, that's going to be a 10x times a 3x gives you a 30x squared, and a 10x plus a 3x gives you a 13x. So those are your two numbers here. So now what we're going to do is we're going to rewrite our original problem. But instead of writing a plus 13x in the middle, we're going to write a plus 10x plus a 3x, because a plus 10x plus 3x is a 13x. So we're not changing the value of this expression, we're just changing the look. So I have a 6x squared, and then I'm going to write the plus 10x plus 3x, because that equals a plus 13x, and then a plus 5. The order that your 10x and 3x go in does not matter. We could have wrote a 6x squared plus a 3x plus a 10x plus a 5. It does not matter. But guess what, guys? Now we have a polynomial with 4 terms. And remember, when we have a polynomial with 4 terms, we use the grouping method to factor it. And that's exactly what we're going to do. I'm going to group my first 2 terms. I'm going to group my last 2 terms, including the operation between those 2 terms. And now we're going to factor out the greatest common factor. The greatest common factor out of my first 2 terms would be a 2x. When I factor that out, I'm left with a 3x plus a 5. The operation I can factor out of my next 2 terms is a plus sign. But I also need to factor out a number, which the only common factor between a 3x and a 5 is a 1. And you have to factor that out. And when I factor out that 1, I'm left with a 3x plus a 5. Remember in the grouping method that if your set of parentheses match exactly, then you know that you did the problem correctly. All right, so one of your binomials is going to be the stuff on the outside of your parentheses. So that's a, that's a 2x plus a 1. Your other binomial is just going to be one set of those parentheses, which is a 3x plus a 5. And this is now fully factored. If you wanted to check your factored form, you could always FOIL out your answer to see if you wind up with your original problem. Moving on to number 2, though. So I have a trinomial, which means 3 terms, and my coefficient of x squared is greater than 1. So we cannot use the box method. We're going to jump into the x method. There is no GCF here, so we can't factor out a GCF. We just jump straight into that x method. And the top of your x is your a times your c, which is your first term and your last term. A 10x squared times a negative 14 is a negative 140x squared. The bottom of your x is your b term, which is your middle term, so that's a positive 31x. So I would need two numbers when multiplied together equal a negative 140x squared, but when added together equal a 31x. And here's where you just play in your calculator. Do negative 140 divided by 2, negative 140 divided by 3, and so forth, and keep going. And you should wind up with negative 4x and 35x being your two terms here. And what's going to happen is we're going to take that negative 4x plus 35x, and we're going to replace the 31x with it, because a negative 4x plus a 35x does equal a positive 31x. So I'm not changing the value of my expression, I'm just changing the look of it and turning it into an expression from 3 terms into 4 terms. So I have a 10x squared minus a 4x plus a 35x minus a 14. It does not matter which order you put that negative 4x and that 35x in, but now I have a polynomial with 4 terms, and we know that the grouping method is how we factor a polynomial with 4 terms. So grouping my terms together, my greatest common factor out of a 10x squared and a minus 4x would be a 2x, and I'd be left with a 5x minus 2. The operation I'm going to take out of my next 2 terms is a plus sign, and the number that they both have in common is a 7, and I'm left with a 5x minus a 2. I know I did this correctly if both my parentheses match exactly, which they do. One of my binomials is all the stuff that I took out of my parentheses, so a 2x plus a 7. And my other binomial is just one set of those parentheses that match exactly, which is a 5x minus a 2, and that is fully factored. Moving on to number 3. There is no GCF. This has 3 terms, and the coefficient of your first term is greater than 1, so we jump into the x method. In the top of your x is your a times your c term, which is a 3x squared times a 5. That's a 15x squared. In the bottom of your x is your b term, which is a positive 16x. So I need 2 numbers when multiplied together equal a 15x squared, but when added together equal a 16x. That's going to be a 1x and a 15x. Rewriting my polynomial, but instead of writing the 16x, I'm going to write a 3x squared plus a 1x, plus a 15x, plus a 5, and it does not matter the order that 1x and 15x are in. But now I have 4 terms, so I'm going to use the grouping method to continue the factor. Out of my first 2 terms, the greatest common factor would just be an x, and I'd be left with a 3x plus a 1. Out of my next 2 terms, I'm going to factor out an operation, which would be a plus sign. And I'm going to factor out the greatest number that both terms have in common, which is a 5, and I'm left with a 3x plus a 1. I know I did this correctly if both my parentheses match, which they do. One of my binomials is the stuff that's on the outside of parentheses, so that's an x plus a 5. My other binomial is a 3x plus 1. That is fully factored. All right, number 4. We do have a greatest common factor that we need to factor out right away, and that is a 4. And I'm left with a 2x squared minus a 9x minus a 5. So now I'm going to jump straight into the x method. In the top of my x is my a times my c, which would be a 2x squared times a negative 5, which is a negative 10x squared. In the bottom of my x is my b value, which is a negative 9x. All right, so I need 2 numbers when multiplied together equal a negative 10x squared, but when added together equal a negative 9x. That's going to be a negative 10x and a 1x. So I'm going to rewrite the 2x squared minus 9x minus 5 as a 2x squared minus a 10x plus a 1x minus a 5. Using the grouping method, I'm going to factor out a 2x from my first two terms, and I'm left with an x minus a 5, which means I would need to factor out a plus 1 out of my next two terms to be left with an x minus a 5. And my parentheses match. Now for this one, we need to make sure that we write our GCF first, then we write our binomial, which is the stuff that's on the outside of parentheses, and we write our other binomial, which is one set of our parentheses. Now I'm going to show you an alternative way to do number 4 down below. Underneath this problem, we'll skip number 5 for right now. Okay. Rewriting that problem, I have an 8x squared minus a 36x minus 20. Let's say that you forgot to take your GCF out from the beginning, and you jump straight into your x method. And so you have an a times a c, which would be an 8x squared, times a negative 20, which is a negative 160x squared. And your b value is a negative 36x. Two numbers when multiplied together equal a negative 160x squared, but when added together equal a negative 36x. That's going to be a negative 40x and a 4x. Rewriting your polynomial without that 30x squared in it, I have an 8x squared minus a 40x plus a 4x minus a 20. Using the grouping method. My greatest common factor out of my first two terms would be an 8x, and I'm left with an x minus a 5. Out of my next two terms, I would need to factor out a plus 4, and I'm left with an x minus a 5. So now I have an 8x plus a 4 as one of my binomials, and an x minus a 5 as my other. Now I would count this wrong, because this is not completely factored. All right, so if you did not take the GCF out from the beginning, like you did here, and you left your answer like this, I would mark it wrong. But that doesn't mean that you have to start all over. If we look at the one binomial of 8x plus 4, these have a greatest common factor of 4 in common. So if I factor out that 4 and rewrite that 8x plus 4, I'm left with a 2x plus a 1, and I can leave my x minus 5 binomial alone. And look at, we still get the same answer as we did for number 4, which is the correct answer because you factored completely. But I didn't need to start all over from the beginning because I forgot to take my GCF out from the beginning. But make sure to look back at your binomials at the end to see if there was a GCF that you forgot to take out, and then take it out at the end. So you can take your GCF out at the end if you happen to forget to take it out from the beginning. All right, we're going to finish with number 5. On number 5, there is no GCF, so we can jump straight into the x method. At the top of my x is my a times my c, and 8x squared times a 15 is a 120x squared. And in the bottom of my x is my b, which is a positive 22x. So I need two numbers when multiplied together equal a 120x squared, but when added together equal a 22x. That's a 12x and a 10x. Rewriting my trinomial without the 22x in there, I have an 8x squared plus a 12x plus a 10x plus a 15. Grouping my first two terms and my last two terms, my greatest common factor out of my first two terms would be a 4x, and I'd be left with a 2x plus a 3. Out of my next two terms, I'm going to factor out a plus 5, and I'd be left with a 2x plus a 3. So one of my binomials, it says, what are the possible dimensions of the rectangle? Well, one of the dimensions would be a 4x plus a 5, and my other dimension would be a 2x plus a 3.